Hello, welcome to my very first video. In this video, I will tell you the very foundation of chemistry. So basically, we're gonna talk about the atoms, the electrons surrounding it, and then we go deep into like how the electrons are flying around the atoms. I mean, just about the atoms first. Okay, so basically, let's go into it. So atom. So what is an atom? So you have heard about, say, maybe carbon atom, oxygen atom, hydrogen atoms, or you have heard about molecules as well. And you have heard about ions. So what are they? So basically, the atoms are just the elements, for example, hydrogens, but they're just themselves. Like for example, if I have a hydrogens atom, it probably has the inside, which is called the nucleus. And the nucleus are basically, as you can see, it's like the center of the atoms. And there are many electrons flying around it. So in this case for hydrogen atom, it has say hydrogen 1,1. So it has only one protons in the center. And it doesn't have any neutrons, so basically it has a proton which bears the positive charge. It also has one electron flying around it in orbits. So there are electrons, and the electrons will fly around the nucleus in the orbits. We call them orbitals. There can be many electrons surrounding it, flying around it. So there can be many orbitals as well. Just like the planets. For example, in the middle we have the Sun, and there are Mercury, Venus, Earth, Mars flying around. So there could be so many orbitals surrounding it. Okay, so that's about hydrogen atoms. Let's talk about another one. For example, carbon. The carbon atom. So we have carbon 12-6. So you're gonna have 6 protons on inside the nucleus. I'm gonna have to redraw it because it's gonna be too small here. Okay, there are gonna be 6 protons, which positive, 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 and then they're positive. Oh, one more. Okay, 6 protons. So what else is there in the nucleus that make up 12? It's the neutron. Neutrons are not charged, so they don't have negative or they don't have positive charge. They're just there to make up the mass of the nucleus. Okay, so about carbon, as I told you, there are 6 protons inside the nucleus. So what makes up the 12 then? It's gonna be having 6 more neutrons, which is uncharged particles. They're uncharged things inside the nucleus. So a carbon atom is supposed to be neutral. So if there are 6 positive charge, there should also be 6 negative charge thing as well, which is the electrons. So say 1, 2, 3, 4, then 5, 6. So as you can see, some electrons are very near to the center. The other electrons can be further apart. So we will learn about it later, but just so you know, Okay, there are several orbits that they can fly around like this. Okay, do you have any questions? Please comment down below, okay? Before I go to the more difficult, deeper part. Okay, so next is about molecules. So basically, you can hear about CO2 molecules, water molecules, ammonia molecules, but you don't hear carbon molecules, or you don't hear hydrogen molecule, or you don't hear oxygen molecules much. Okay, this is oxygen molecules, but it has to be O2. So what is the difference between molecule and atom then? So atoms are basically just single element. It's just a single element. The thing that is made out of only one element, that is an atom. Okay. So molecules, they should be made out of at least two different elements. In this case, carbon and oxygen. In this case, hydrogen and oxygen. And in this case, nitrogen and hydrogen. Okay. So that's the main difference. So what about ions? What are they? The ions are things that has charge on it, either positive or negative. Like for example, if I have a sodium atom, and it, how can I say, it loses one electron, which is negative, it's gonna become more positive. Because why? When you lose a negative thing, you become more positive. And the same, the vice versa thing, the reverse thing could also happen as well. So when you gain a negative thing, you become more negative. For example, like this, chloride atoms, you plus one electrons, it will become chloride minus ion. So once again, what is ion? Ions are charged particles. They are charged thing. They have positive, either positive or negative charge, okay? They can be made out of what? As a result of gaining or losing electrons from the neutral state. Okay? Any question? Just comment below, okay? I'll be busy making videos but I will still have time to answer your questions, and it might help in my other videos so I can improve the quality of the videos, okay? Okay, so that's about atoms, molecules, and ions. Okay, I would like to go back into the orbitals, talk more about it. So how do we find out about the orbitals? Well, as a scientist, I'm just joking. Okay, so somehow we found out about the orbitals, which are the electrons flying around the central nucleus. The thing is, they are not the same. I mean, the distribution of the electrons is not the same. So for example, I have, say, oxygen 16-8. So if I have an oxygen 16-8, the orbitals surrounding my center, it's gonna have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16 over there. Okay, should have 16 different particles inside the nucleus, and they have 8 positive. I'm gonna put 8 there. 1, 2, 3, 4, 5, 6, 7, and then 8. Okay, and then there should be 8 electrons surrounding it as well. They follow this pattern. So the first orbitals surrounding the nucleus has a maximum of 2 electrons. I mean, it cannot fit in more because you're too near to the center already. You cannot fit in more. There's not enough space. The next orbitals can also fit in only 2 as well. Sadly, you need 4 more electrons. So you will need, how can I say, you will need basically 4 more electrons. These electrons are not like in place, okay? They're just flying around, floating around randomly. Because orbitals are what? Orbitals are just the, how can I say, imaginary part that these particles will take. They just basically fly around randomly around the nucleus with a relative distance. I mean, nearer or further apart from the nucleus. So at this moment, they may be here. But, how can I say, in the next moment, they may be somewhere else. I mean, they just fly around randomly. So here comes the question. How do you know how to draw, the orbitals surrounding it? We have a concept called electron configuration. Electron configuration. So electron configuration, or what? What is that? It just tells you the map where you can find the electrons and where they are located. So in this case, the nearest orbitals to the center is called 1s. The next one, this is a 2s. And the last one, the outermost, is called the 2p. In the first shell, you have 2 electrons up and down, up, down, up, 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 down. I'm going to tell you the rules on how to fill this one later. Okay, but now one thing. Electrons are negative, and as you know, negative and negative, they don't go together in one direction. They might just basically go in a different direction because they repel each other. You know, that's why they are going in different direction, up and down here. Okay. So 1s2, 2s2, and 2p4. Okay. If you have questions, just put it down the comment below, okay? Okay, I'm just gonna talk about how do you know how to construct these things and what are s and p orbitals. These days, according to the textbook, we have s, we have p, and we have d, and we have f orbitals. They found it out by laboratory techniques. So s orbitals are the smallest square-shaped orbitals. P orbitals having that number 8 shape. It's just like the electron can float around in the nucleus like number 8. For P and then S, it's just like they go around like a planet randomly. D and F I don't want to talk about much because it's not a significant thing in the textbook, in the exam anyway, but it's complicated. We found out that the orbits of these electrons can be very weird. Okay, but enough about that. Now, how do we know how to construct which one come next, which orbital will come next? There is something we call Aufbau principle. If anyone knows German, this word means to build up. Aufbau, to build up. So basically, this is the way you know how to build up which orbitals will come next. So first, you write it down. So 1, the first orbital has only one s. The second orbital you have 2s and 2p. And of course the third you have s, p and d. Makes sense, right? And the fourth you have s, p, d and f. It's just gonna go on until 7. But you have only s, p, d, f to begin with now. 5s, 5p, 5d and 5f. 6s, 6p, 6d and 6f. And finally 7s, 7p, 7d and 7f. Okay, so how do we go? Okay, so in this case we start here. So this is where we start, and we go down like this. So first you start with 1s, and then you go to 2s. 1s you go down to 2s, and then 2p, 3s, and then 3p, 4s. And then it's just gonna start from here and then go slowly oblique in an oblique fashion. So 4s and then 3d, 4p, 5s. Okay, let me start again. From start, go 1s, 2s, 2p, 3s, 3p, 4s, and then 3d, 4p, 5s, and then it just keep going on, and then 4d, 5p, 6s, and then so on. It's just gonna keep go on until you reach the highest orbitals, which is 7f. But trust me, I mean normally they would never ask you to draw into something like 4f or something. I think maximum is 5s. So the Aufbau principle tells you what orbitals will come up next. But in this case we have only 8, so it will fit into 1s2, 2s2 and 2p4, and that's it. Okay. It requires some practice to draw this one and then how to count which one come up next. You can just, come back to the previous minutes in this video. Okay, let's do one more example. Say chlorine. 35.5 and 17. Draw its electron configuration. How you do this one? Chlorine 35.5 and 17. So you know you have 17 electrons and 17 protons. So we start with 1s, 2s2. So that's 2 and 4. Okay, 4. For p, you have 3 square. And it's gonna be 6. Up, 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 down, down, down. That's the rules why I have to put up, up, up first and then down, down, down. It's called Hunds rules. But, oh, excuse me. I can be clumsy at times. It's called Hunds Rule. The guy name is Hund, and he proposed that you should always half fill the orbital first. So if it's empty, you half fill it first. So if it's empty like this, you have to half fill it first. Put one up first. And then all of these things has to be half filled first. Like this. Half, 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 and then you continue to go down, down, down. That's his rule, Hunds Rule. Okay, that's make it 10. You need 5 more. So 3s. 2. You need, okay, that's 12. You need 5 more. Okay, here come the 3p. So I need 5 more. 1, 2, 3, 4, and 5. So this is the last electron I put in there. There you go. You can see it now. So this is the last electron I put in there. So up, 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 and then down, down. This one gonna be, okay, 3p5. So 10 plus 7, 12. It's 17. Okay. Please do a few more example. Let's say, try this one. Silicon 2814. Try it. Pause the video and try it. And then also try this one. Bromine 25. I think 50 something. No, it's 35 and 80. Excuse me. Try bromine 35. Try bromine 80, 35. Bromine 80, 35. Pause the video for a while and do it. Okay. So after a bit of practice, here's how we make it. Here's how we draw it. Okay. For silicon, same thing. You have 14 electrons to put in, so 1s2, 2s2, that's 4. Up, 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 down, down, down. That's 2p6. So you have 10 already. You need 4 more. The next one, according to Aufbau principle, is gonna be 3s, and you have 2 here. You need 2 more. So the next come is 3p. So you need 2 more. So up, up, and this is the last electron I put there. 1, so 10, 14. Okay, that's it. Silicon 14. You get the same result. Okay. Now bromine, Br 35. So it should be like this. 1s2. It's gonna be long. 2s2. 2p6. Up, 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 down, down, down. That's 10. 3s2. I'm sure it's gonna be a long, long way to go. 3p6. So that's 18. After 4p, you're gonna have after 3p, you're gonna have 4s. That's 20. After 4s, you have 3d. The d has 5 square. So that's 20, and this is gonna be 3d10 because you know, let's make it 30. Up, 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 down, 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 according to Hunds rules. So that's 30. You need 5 more. So what comes after 3d? It's 4p. So need 5 more, so it's gonna be 1, 2, 3, 4, 5. So this is the last electron I fill in. Okay, do you have the same answer? Okay, that might be the end of my video. I don't want to make it too long, so I hope it was helpful for you. Please stay tuned for the next video. I'm going to talk about something more related to this one, like quantum numbers and other things. Okay, see you!